Polar regions of the Earth, Antarctica and the Arctic, are often spoken of together because both are cold, icy, remote, and crucial to the planet's climate system. Yet despite this superficial similarity, they are profoundly different in almost every meaningful sense: geography, geology, climate behavior, ecosystems, human presence, legal governance, economic relevance, and future prospects. Understanding the differences between Antarctica and the Arctic is essential for understanding how Earth works as a system and how human actions today may shape the planet's future for centuries. Antarctica is a vast continent located at the southernmost part of the Earth, centered almost exactly on the South Pole. It is surrounded entirely by the Southern Ocean and isolated from other landmasses by thousands of kilometers of open water. In contrast, the Arctic is not a continent at all but a region centered on the North Pole, consisting primarily of the Arctic Ocean, which is surrounded by the landmasses of North America, Europe, and Asia. This fundamental geographic difference, land surrounded by ocean versus ocean surrounded by land, shapes nearly every other distinction between the two regions. Antarctica's ice rests on solid bedrock, forming massive ice sheets several kilometers thick, whereas Arctic ice is largely sea ice that floats on ocean water and varies dramatically with the seasons. The physical properties of Antarctica are extreme even by polar standards. It is the coldest, driest, and windiest continent on Earth. Temperatures in the interior can drop below -80 degrees Celsius, and the record for the lowest natural temperature ever recorded on Earth was measured in Antarctica. The continent is also technically the largest desert in the world, receiving very little precipitation. Most of its ice accumulated over millions of years from tiny amounts of snowfall that never melted. The Antarctic ice sheet contains about 60 to 70% of the world's fresh water, locked in ice, and if it were to melt completely, global sea levels would rise by nearly 60 meters, reshaping coastlines worldwide. The Arctic, while still extremely cold, is comparatively milder. Average winter temperatures range between -30 degrees Celsius and -40 degrees Celsius, and summer temperatures can rise above freezing in many areas, allowing tundra vegetation to grow. Because much of the Arctic consists of ocean, it is strongly influenced by ocean currents and atmospheric circulation, which moderate temperatures compared to Antarctica. Arctic sea ice is thinner and more dynamic, forming and melting seasonally. This seasonal nature of Arctic ice makes it especially sensitive to climate change, and over the past few decades, Arctic sea ice extent and thickness have declined dramatically. Climate behavior in the two poles also differs in critical ways. The Arctic is warming at more than twice the global average rate, a phenomenon known as Arctic amplification. As sea ice melts, darker ocean water is exposed, absorbing more solar radiation and accelerating warming in a powerful feedback loop. This warming affects not only the Arctic but also global weather patterns by weakening the temperature gradient between the poles and the equator, influencing jet streams and contributing to extreme weather events such as prolonged heat waves, cold snaps, and unusual storm patterns in mid-latitude regions. Antarctica, on the other hand, has shown a more complex and regionally varied response to global warming. While parts of West Antarctica and the Antarctic Peninsula have warmed rapidly and experienced significant ice loss, much of East Antarctica has remained relatively stable so far. However, recent research suggests that even Antarctica is becoming increasingly vulnerable, particularly due to warming ocean waters that erode ice shelves from below. The collapse of ice shelves does not directly raise sea levels, but it removes the buttressing effect that slows the flow of inland glaciers, allowing them to accelerate into the ocean and contribute to sea level rise. The influence of both poles on Earth's climate system is enormous. Antarctica plays a major role in regulating global ocean circulation through the formation of cold, dense water that sinks and drives the global thermohaline circulation, sometimes referred to as the global ocean conveyor belt. This circulation redistributes heat around the planet and helps stabilize climate patterns. The Arctic also influences ocean circulation, particularly in the North Atlantic, where cold, salty water sinks and drives currents such as the Atlantic Meridional overturning circulation. Disruptions to these systems could have profound consequences for global climate, affecting rainfall patterns, agricultural productivity, and sea levels worldwide. The ecosystems of Antarctica and the Arctic are shaped by their distinct physical environments. Antarctica has no native terrestrial mammals, reptiles, or amphibians. Life is concentrated primarily along the coast and in the surrounding ocean. Penguins are perhaps the most iconic Antarctic animals, along with seals, whales, and seabirds. On land, life is limited to hardy organisms such as lichens, mosses, algae, and microorganisms that can survive extreme cold, dryness, and high ultraviolet radiation. The Antarctic marine ecosystem is highly productive, largely due to the abundance of krill, which form the foundation of the food web and support a wide range of larger animals. The Arctic, by contrast, supports a much more diverse array of life, both terrestrial and marine. Polar bears, Arctic foxes, reindeer, musk oxen, wolves, and numerous bird species inhabit the Arctic tundra. The region also supports indigenous human populations who have lived there for thousands of years, developing cultures, languages, and livelihoods adapted to the harsh environment. Marine life in the Arctic includes seals, walruses, whales, and fish species that are important both ecologically and economically. The presence of land, vegetation, and seasonal warmth allows for a more complex and interconnected ecosystem than in Antarctica. Human presence marks one of the starkest differences between the two poles. Antarctica has no indigenous population and no permanent residents. Human activity is limited primarily to scientific research and a growing tourism industry. Scientists from dozens of countries live temporarily at research stations, studying climate, geology, astronomy, biology, and other fields. These activities are governed by the Antarctic Treaty System, which designates Antarctica as a scientific preserve, bans military activity, and prohibits mineral mining. This treaty represents one of the most successful examples of international cooperation in history, prioritizing peace and science over territorial claims and economic exploitation. The Arctic, in contrast, is home to millions of people and falls under the sovereignty of 8 Arctic nations: Canada, the United States, Russia, Norway, Denmark, via Greenland, Sweden, Finland, and Iceland. Indigenous peoples such as the Inuit, Sami, Nenets, and others have lived in the Arctic for millennia, relying on hunting, fishing, and herding for survival. Modern Arctic communities are also involved in industries such as mining, oil and gas extraction, shipping, and tourism. Governance in the Arctic is complex, involving national laws, international agreements, and institutions such as the Arctic Council, which promotes cooperation on environmental protection and sustainable development. The economic effects of the two polar regions differ greatly due to these governance structures and physical realities. Antarctica's economy is limited mainly to scientific research and tourism. Tourists, mostly arriving by ship, visit coastal areas and the Antarctic Peninsula to experience the landscape and wildlife. While tourism generates revenue, it is tightly regulated to minimize environmental impact. Scientific research conducted in Antarctica has immense indirect economic value by improving our understanding of climate change, weather forecasting, sea level rise, and Earth's history, information that informs policy decisions and economic planning worldwide. The Arctic, by contrast, is already economically significant and is becoming more so as ice melts and access improves. The region contains vast reserves of oil, natural gas, coal, and minerals such as nickel, copper, rare earth elements, and diamonds. Russia, in particular, has heavily invested in Arctic energy development, viewing the region as central to its economic and strategic future. Canada and the United States also exploit Arctic resources, while Norway has developed offshore oil and gas fields in the Barents Sea. Greenland has attracted interest for its mineral resources, including rare earth elements critical for renewable energy technologies. Mining and resource extraction represent one of the most controversial aspects of polar development. In Antarctica, mining is explicitly banned under the Protocol on Environmental Protection to the Antarctic Treaty, also known as the Madrid Protocol. This ban reflects the global consensus that Antarctica should be preserved for peaceful and scientific purposes, at least for now. Although some countries have conducted geological surveys that suggest the presence of valuable minerals, there is currently no legal framework that would allow their extraction. The ban can theoretically be reviewed in the future, raising questions about whether economic pressures might one day challenge the current protections. In the Arctic, mining and resource extraction are already realities, but they come with significant environmental and social costs. Oil spills, habitat disruption, pollution, and impacts on indigenous livelihoods are major concerns. The harsh environment makes cleanup operations difficult and expensive, increasing the risks associated with industrial activity. Climate change adds another layer of complexity, as melting permafrost destabilizes infrastructure such as roads, pipelines, and buildings. At the same time, Arctic shipping routes such as the Northern Sea Route and the Northwest Passage are becoming more navigable as ice retreats, reducing travel distances between major markets and potentially reshaping global trade patterns. Geopolitics plays a growing role in both regions, though in different ways. Antarctica is characterized by cooperation, with territorial claims effectively frozen under the Antarctic Treaty. Countries such as the United States, Russia, China, and members of the European Union maintain research stations, sometimes motivated by both scientific interest and strategic considerations. China, in particular, has expanded its Antarctic research presence, signaling long-term interest in polar science and potential future influence. The Arctic, however, is increasingly a site of geopolitical competition. Russia has expanded its military and infrastructure presence in the Arctic, reopening Soviet-era bases and investing in icebreakers. The United States and NATO allies have responded with increased attention to Arctic security. China, while not an Arctic nation, has declared itself a near-Arctic state and seeks involvement in Arctic shipping, research, and resource development. These dynamics raise concerns that competition over resources and strategic advantage could undermine cooperation and environmental protection. The future of both poles is deeply intertwined with global climate change. The Arctic is expected to continue warming rapidly, with the possibility of ice-free summers within this century. Such a transformation would have profound implications for ecosystems, indigenous cultures, global weather patterns, and sea levels. Some species may adapt or migrate, while others face extinction. Human activities may expand, increasing economic opportunities but also environmental risks. Antarctica's future is more uncertain but potentially even more consequential. While much of the continent remains extremely cold, the stability of major ice sheets is a critical concern. The collapse of parts of the West Antarctic ice sheet could trigger irreversible sea level rise over centuries, affecting hundreds of millions of people worldwide. Decisions made today about emissions reductions, scientific research, and environmental protection will influence whether Antarctica remains largely frozen or becomes a major driver of global change. Ethically, the two poles raise different but related questions about humanity's relationship with nature. Antarctica represents an ideal of shared stewardship, where nations have agreed to set aside economic exploitation in favor of knowledge and peace. The Arctic reflects the challenges of balancing development, environmental protection, and the rights of indigenous peoples in a rapidly changing world. Both regions serve as mirrors, reflecting humanity's capacity for cooperation, restraint, exploitation, and foresight. In summary, while Antarctica and the Arctic are both polar regions dominated by ice and cold, they are fundamentally different in their geography, climate, ecosystems, human presence, governance, and economic roles. Antarctica is a remote, uninhabited continent governed by international cooperation and dedicated primarily to science and conservation. The Arctic is a dynamic, inhabited region shaped by national interests, economic activity, and rapid environmental change. Both exert enormous influence on Earth's climate and oceans, and both face uncertain futures in a warming world. Understanding their differences and similarities is essential for making informed decisions about climate policy, resource management, and global cooperation, because what happens at the poles does not stay at the poles, it affects the entire planet.
If you have enjoyed our videos, don't forget to subscribe and share.